Why have federal agencies and agricultural security experts begun classifying specific tree species and planting practices as matters of national resilience? It is not merely an issue of botany, it is a question of law. From the invasive Bradford pear, which is now banned in multiple states due to its disruption of native ecosystems, to the global trade in commodities grown on illegally converted land, the agricultural sector is battling an invisible enemy. We investigate how governance gaps allow these illicit activities to flourish and the rigorous tracking methods required to secure the supply chain. When we assess the scarring of the tropical belt, the primary error lies in attributing the damage solely to the timber industry. While the extraction of wood is a significant economic activity, a more pervasive driver dominates the landscape: commercial agriculture. The chainsaw is often merely the precursor to the plow. Between the years 2000 and 2012, commercial agriculture was responsible for approximately 71% of all tropical deforestation. This massive conversion of biomass into farmland creates a paradox where the forest is destroyed not for what it contains, but for the space it occupies. However, the critical metric that concerns security experts is not merely the loss of canopy, but the violation of sovereignty. Current data indicates that nearly half, specifically 49% of this agricultural conversion, was linked to illegal activity. This is not the sporadic encroachment of small-scale subsistence farming. It is industrial-grade land clearing engineered for export commodities. The mechanics of this illicit conversion rely heavily on governance gaps within producer nations, where operators can bypass environmental regulations and land tenure laws. Once the land is cleared and the crops are harvested, the origin of the product becomes obscured. The result is a flood of laundered agricultural products entering Western markets, indistinguishable from legally sourced goods. This phenomenon is most visible when analyzing the composition of specific global commodities. Research suggests that approximately 40% of all internationally traded palm oil originates from ex-forested land that was illegally cleared. The figures for other staples are equally alarming. 33% of tropical timber, 20% of all soy, and 14% of all beef traded internationally are derived from operations that violated national deforestation laws. This demonstrates that a substantial portion of the global grocery, cosmetic, and construction supply chains is compromised by illicit extraction. The environmental impact of this unrestrained conversion operates on a scale that rivals major industrial nations. If the international trade in agricultural commodities resulting from illegal deforestation were considered a single economic entity, its emissions profile would rank as the 6th largest contributor to climate change globally. This illicit trade releases approximately 1.5 gigatons of carbon dioxide into the atmosphere annually. To contextualize this volume, that figure is comparable to the total annual fossil fuel-based emissions of the entire European Union. The global market is, therefore, unwittingly funding its own ecological destabilization through unregulated consumption. The carbon sequestration potential of millions of hectares is effectively liquidated to support temporary agricultural yields, creating a feedback loop of atmospheric warming that further stresses the remaining legal forests. The economic reality of this trade provides the rationale for its persistence. Commodities exported from these illegally cleared lands are valued at an estimated $61 billion annually. This massive financial incentive ensures that without rigorous, technology-driven intervention, the machinery of conversion will continue to operate. The supply chain acts as a vast laundering mechanism, turning the unauthorized destruction of biodiversity into palletized, shippable units of consumption. The consumer, purchasing a cosmetic product or a cut of beef, participates in a transaction where the true cost, the violation of national laws and the release of gigatons of carbon has been externalized and hidden. While these statistics illustrate the crisis at a planetary scale, the true mechanism of ecological collapse is best understood by observing the physiological degradation of a single species. To understand how illegal extraction physically alters the landscape, we must look away from the aggregate global data and focus our lens on the arid regions of North Africa, where the distinction between a protected zone and a disturbed one is measured not in dollars, but in the stunted growth of a specific biological indicator. In the arid and ecologically sensitive regions of North Africa, specifically within the boundaries of the Dinder Biosphere Reserve, the extent of agricultural lawlessness is not measured by satellite imagery alone, but by the physical architecture of the local flora. Use of the Balanites aegyptiaca, known commonly as the desert date, has shifted from a traditional resource to a critical biological indicator. This species, essential for the stability of the reserve, offers a precise biometric record of enforcement failure. When illegal activities breach the perimeter of the reserve, the resulting damage is quantified through a rigorous comparison between the protected core zones and the areas subjected to illicit extraction. The mechanism of this degradation is systematic. Illegal harvesting operations infiltrate the reserve to extract timber for firewood or to strip branches for livestock fodder and medicinal use. This is not a passive or sustainable collection. It is an aggressive removal of biomass that alters the fundamental structure of the stand. Field studies conducted within the Dinder Biosphere Reserve reveal a stark divergence in dendrometric parameters. In the undisturbed sites, where the rule of law maintains the integrity of the ecosystem, the trees reach their full physiological potential. Here, the height and crown width of the Balanites aegyptiaca are documented to be double the size of those found in the disturbed zones. This reduction in physical stature acts as the first signal of a deeper ecological malfunction. The crown of the tree is not merely a shading mechanism, it is the primary engine of reproductive output. Research establishes a strong positive correlation between crown width and the density of fruiting branches. A wide, robust canopy serves as a necessary prerequisite for significant fruit production. However, illegal harvesting severs this relationship by mechanically reducing the crown, thereby forcing the tree to divert energy from reproduction to survival. Consequently, the number of fruiting branches in the protected sites is recorded as being 3 times more abundant than in those areas experiencing human disturbance. The trees in the illegal zones are effectively sterilized by the stress of constant extraction. The consequences of this reproductive suppression are immediately visible on the forest floor. The stability of any forest system relies on recruitment, the process by which new seedlings establish themselves to replace the aging overstory. In the disturbed zones of the Dinder Reserve, this cycle has been shattered. Taking the census of the undergrowth reveals that sapling density drops 3-fold in areas subject to illicit extraction. Furthermore, seedling density is reduced by half compared to the protected core. This data signal indicates a collapse in natural regeneration. The illegal activity does not simply remove the current generation of biomass, it actively prevents the emergence of the next. The result is a population structure that is severely skewed. The removal of mature, large crown trees halts the recruitment of young biological successors, leading to a stand characterized by fewer adult trees and a complete lack of viable replacements. The disturbed zones become populated by smaller, less productive individuals that lack the structural integrity to support the ecosystem. This creates a feedback loop of decline, where the diminished canopy is unable to support the biodiversity required to maintain the reserve status. The Balanites aegyptiaca in these zones stands as a biological testament to the severity of the transgression, resembling a factory that has been stripped of its essential machinery. While these dendrometric measurements provide a clear assessment of the damage above the surface, the ecological impact is not limited to the visible canopy. The stress placed on these biological indicators catalyzes a chain reaction that alters the fundamental composition of the environment itself. The visible damage to the tree structure is merely the external symptom of a much more permanent physiological disruption. To fully comprehend the cost of this illegal harvest, one must analyze the ground beneath the roots. Ecological damage is typically assessed by what is missing above ground, yet the soil chemistry tells a more permanent story. Ecological damage is typically assessed by what is missing above ground, measuring the gaps in the forest utilizing satellite imagery and visual surveys. However, the most permanent scar left by illicit extraction is written in the chemistry of the substrate itself. To understand the true cost of this environmental crime, one must look below the surface, where the soil acts as the chemical archive of the ecosystem. In a functioning reserve, mature trees like the Balanites aegyptiaca operate as sophisticated nutrient pumps, executing a continuous cycle of biological maintenance that sustains the entire biome. This process relies on the tree's ability to draw minerals from deep within the subsoil and deposit them onto the surface through leaf litter decomposition. Simultaneously, the root systems secrete complex organic compounds known as exudates, which feed the microbial life necessary for a fertile microenvironment. This is a crucial and standardized step in terrestrial chemistry, ensuring that the ground remains receptive to new growth. However, when illegal harvesting operations systematically remove these biological engines, the chemical composition of the Earth shifts with dangerous rapidity. Research conducted within the Dinder Biosphere Reserve provides a precise audit of this degradation. Soil analysis reveals a catastrophic depletion of the essential inputs required for plant vitality, specifically the levels of nitrogen and phosphorus. The data indicates that undisturbed sites retain nearly double the nitrogen and phosphorus content compared to those zones ravaged by illicit extraction. This is not a minor fluctuation in soil quality. It acts as a complete liquidation of the land's productive assets. The removal of the canopy disrupts the temperature regulation of the forest floor, accelerating the oxidation of soil organic matter. Consequently, the levels of organic carbon drop significantly, breaking the soil structure and reducing its capacity to retain water. Yet, the analysis reveals that as beneficial nutrients are stripped away, they are replaced by a more hostile agent. The destruction of the vegetative cover triggers a severe chemical inversion characterized by a rapid rise in soil salinity. In the disturbed zones, the soil exhibits a measurable spike in electrical conductivity, a technical metric that signals the accumulation of dissolved salts. The specific chemical profile is alarming. Research confirms that sodium levels in these strip zones are approximately 50% higher than in the protected, undisturbed core. This accumulation creates a saline barrier that most native flora cannot breach, effectively turning the land against itself. The elevated salinity creates an osmotic imbalance that halts water uptake in young saplings, ensuring that the ground remains hostile to recovery. The precision of this degradation is further highlighted by the behavior of other chemical markers. Interestingly, studies indicate that potassium levels do not vary significantly between different tree species within the same site. Similarly, soil pH follows a consistent pattern regardless of the specific botanical resident. However, when contrasting disturbed sites with undisturbed ones, a significant difference emerges across the board. This proves that the chemical collapse is not a function of the species present, but a direct consequence of the physical disturbance itself. The alteration of the carbon-to-nitrogen ratio in these soils creates a self-perpetuating feedback loop that further suppresses seedling survival. The degradation of the microenvironment creates a permanent scar in the biosphere's chemical profile, rendering the land incapable of supporting the complex biodiversity of a reserve. Illegal harvesting essentially sterilizes the soil, converting fertile land into a saline wasteland that prevents the recruitment of the next generation. While this profound chemical erasure occurs in remote biological reserves, a different form of botanical incompatibility is actively proliferating in the center of the developed world. Agricultural security issues are rarely associated with the manicured lawns and commercial strips of suburban developments, yet a potent botanical threat has taken root within the residential landscape. The focus shifts here from the remote extraction of resources in the tropics to the unregulated proliferation of a specific ornamental organism, the Bradford pear, also known scientifically as the calorie pear. Native to the temperate regions of China and Vietnam, this deciduous tree was initially identified by the U.S. Department of Agriculture as an ideal candidate for urban planning due to its extreme hardiness and rapid growth rate. For decades, this species was the standard installation for shopping centers and new housing grids, valued for its symmetrical canopy and profusion of white spring blossoms. The initial assessment by federal agronomists suggested a sterile cultivar, safe for widespread distribution across the varying climates of North America. However, the biological reality of this species has diverged catastrophically from its intended horticultural purpose, creating a scenario where a government-endorsed asset has mutated into a biological liability. The mechanism of this failure lies in the introduction of multiple distinct calorie pear variants into the same geographic zones. While the original Bradford cultivars were genetically incapable of self-fertilization, the introduction of other variants to the market allowed for cross-pollination. This interaction acts as a form of biological pollution, unlocking the reproductive potential of the trees and producing viable seeds that are widely dispersed by local bird populations. The resulting offspring, known as volunteers, bear little resemblance to the disciplined ornamental trees planted along sidewalks. Instead, these hybrid descendants revert to the aggressive traits of their wild ancestors, establishing distinct colonies that function less like trees and more like an invading army. The physical characteristics of these volunteer pears present a direct hazard to both infrastructure and biology. Unlike the parent trees, the offspring develop formidable 3-inch long thorns along their branches. These calcified spikes are sufficiently durable to puncture the pneumatic tires of tractors and passenger vehicles, effectively turning a grove of trees into an area denial weapon. The density of their growth creates nearly impassable thickets that physically exclude large mammals from the terrain. Even rugged foraging livestock, such as goats, refuse to penetrate the sharp, tangled perimeter of a mature calorie stand, leaving the invasive thicket to expand unchecked. This aggressive expansion displaces native vegetation, effectively monopolizing the sunlight and soil nutrients required by indigenous flora. The structural integrity of the tree itself creates a secondary layer of risk for property owners. The colliery pear is notorious for its weak wood and poor branch architecture, which makes it prone to catastrophic failure during wind events or ice storms. The collapsing limbs act as heavy projectiles, damaging equipment and severing utility lines, proving that the tree is an economic liability as much as an ecological one. Recognizing the severity of this intrusion, state governments have moved to criminalize the existence of the species within the commercial nursery trade. Legislative bodies in states such as Pennsylvania, South Carolina, and Ohio have officially classified the Bradford pear as an illegal invasive species, explicitly recognizing its significant ecological damage. These rulings ban the planting, sale, and propagation of the tree, effectively marking the transition of a once prized commodity into contraband. The illegality described here is distinct from the extraction of timber. It is the crime of propagation, planting a biological time bomb that degrades the integrity of the local ecosystem. The response to this threat has shifted from passive monitoring to active eradication and replacement. Community-driven initiatives have mobilized to physically dismantle the monocultures established by the pear and restore the native canopy. Organizations like the nonprofit Friends of the Lower Olentangy Watershed, operating in Ohio, have spearheaded logistical operations to reverse the damage. Their program involves the distribution of over 1,500 free native trees, specifically selecting robust alternatives like the American beech and the sweet gum to reclaim the landscape. These programs operate with the precision of a coordinated logistical strike, relying on volunteers not only to execute the initial planting, but to provide the long-term custodial care necessary for establishment. The goal is to ensure the successful displacement of the invasive species by manually inserting its biological competitors. The persistence of the colliery pear demonstrates how horticultural choices, when left unregulated, can mutate into long-term ecological liabilities that require state-level intervention to correct. The transition from an ornamental asset to a banned organism highlights the fluidity of agricultural legality, where a government endorsement can curdle into a prohibition. Addressing these biological threats requires a governance framework that spans from local bans to international trade laws, ensuring that the next supply chain does not transport a similar defect. The challenge of enforcement lies in the complexity of the global supply chain, where illegal goods are mixed with legal harvests. The magnitude of the agricultural underground is defined by a single, staggering financial metric: $61 billion. This is the estimated annual value of commodities generated from land that was cleared in violation of national laws. However, the primary challenge for enforcement agencies is not merely the volume of this trade, but the insidious invisibility of its origin. Once a harvest is severed from the earth, it enters a labyrinthine supply chain designed to obliterate its history. The physical distinction between a legally harvested soybean and one grown on a scorched reserve is non-existent to the naked eye, and it is within this biological uniformity that the laundering mechanism operates. The critical point of failure occurs at the first stage of aggregation. Agricultural commodities grown on illegally converted land are transported to local processing facilities, grain elevators, slaughterhouses, or palm oil mills, where they are immediately commingled with legal harvests. In the vast silos of the processing center, the provenance of the individual unit is lost. The facility acts as a black box. Raw materials enter from dozens of disparate sources, and a unified, untraceable product exits. By the time the commodity reaches a port for export, the illegal inputs have been effectively laundered into the legitimate market, rendering standard audits useless. Corporations have attempted to mitigate this risk through voluntary sustainability pledges, yet these well-intentioned commitments have proven largely insufficient in curbing illegal deforestation. Research indicates that the substantial profit margins associated with illicit land conversion often outweigh the commitments made by corporations. When the cost of land acquisition is zero because it is stolen from a reserve, the operational margins become unbeatable. Consequently, products that adhere to rigorous sustainability standards are forced to compete with those derived from illegal activities, creating a price disparity that inherently favors the latter and perpetuates the cycle of deforestation. The persistence of this trade is further enabled by profound governance gaps in producer countries. In these regions, the administrative infrastructure is often too weak to verify the legitimacy of the land title. Illegal operators routinely falsify permits or exploit legal loopholes to secure paper documentation for illicit goods. A logger or rancher may obtain a permit for a small plot of land but proceed to clear hundreds of surrounding hectares, using the single valid permit to cover the entire output. This bureaucratic sleight of hand allows millions of tons of contraband biomass to enter the global bloodstream with a stamp of approval. Tracing the true origin is further complicated by the web of intermediaries, aggregators, and exporters that characterize agricultural supply chains. A single shipment of beef or palm oil may change ownership half a dozen times before it even leaves the country of origin. Each transaction adds a layer of opacity, obscuring the link between the final product and the initial crime. The concept of legality is frequently obscured within this complex network, making it nearly impossible for a downstream buyer to verify compliance with environmental laws. Without rigorous tracking mechanisms, consumer products may inadvertently contain ingredients sourced from protected reserves or areas cleared in violation of regulations. The staggering scale of this integration is evident in the export data. Approximately 49% of all tropical deforestation between 2000 and 2012 was linked to illegal conversion, and nearly a quarter of this destruction was directly linked to agricultural products destined for export markets. The global market is essentially consuming the evidence of the crime. This inherent opacity underscores the necessity for a radical shift from voluntary expectations to mandatory legality verification systems. A mandatory framework requires proof of compliance at every node of the transfer, ensuring that the supply chain is transparent rather than translucent. This approach aims to make illegal deforestation economically unviable by closing the market access points for unverified goods. As long as the global market accepts goods without a forensic history, the economic incentive for illegality remains dangerously high. To dismantle this mechanism, authorities are now looking beyond paper trails and turning to advanced surveillance to watch the harvest happen in real time. The era of relying solely on rangers patrolling vast, impenetrable borders is drawing to a close. Modern enforcement has ascended to a higher vantage point, swapping mud-streaked boots for orbital observation. The detection of illicit land conversion no longer mandates a physical presence at the moment of the crime. Instead, it utilizes a sophisticated network of remote sensing technology. This transition represents a fundamental change in how agricultural legality is monitored, moving from reactive patrols to proactive, data-driven surveillance that operates continuously and without fatigue. At the forefront of this digital defense is Global Forest Watch. This platform provides the essential technical capacity to detect illegal land conversion by utilizing advanced satellite imagery. The system operates by carefully monitoring forest cover changes in near real time, scanning the planetary surface for the telltale spectral signatures of sudden clearing. By analyzing changes in canopy cover, the technology enables the precise identification of deforestation events, including those specifically driven by agricultural expansion. The data generated does not offer vague estimates. It can precisely pinpoint the locations and timing of forest loss. This granular level of detail provides critical evidence for monitoring and creates a digital record that enforcement agencies can utilize against illegal activities. However, detection is only effective when paired with enforceable governance frameworks. A digital map of destruction is useless without the legal mechanism to stop the destroyer. This is where the Forest Law Enforcement, Governance and Trade Action Plan, known as FLEG, becomes the operational standard. Specifically, the Voluntary Partnership Agreement component serves as a crucial framework to combat illegal logging and promote legal timber trade. These are not casual understandings. They are bilateral, legally binding arrangements established between the European Union and producer countries. The architecture of these agreements is designed to replace chaos with rigid bureaucratic order. Under the stipulations of a voluntary partnership agreement, producer countries commit to a rigorous verification process. They must issue FLEC licenses for timber exports destined for the EU, verifying that the timber is legal according to national laws. In return for this transparency, the EU guarantees market access for this licensed timber. This exchange creates a powerful economic engine that incentivizes improved forest governance. It effectively forces the formalization of legality within the producer country's timber sector, ensuring that the supply chain is verified before the commodity ever reaches the shipping container. When these legal frameworks intersect with orbital data, the result is a formidable barrier to crime. Satellite data provides concrete evidence that can be utilized for prosecution in cases of illegal deforestation. By pinpointing the exact moment a protected canopy is breached, this technology offers irrefutable proof of illegal activity that stands up in a court of law. This evidence is vital for customs enforcement, allowing officers to cross-reference shipping manifests with satellite timestamps. This capability creates a significant barrier against the entry of illegally sourced agricultural products into global markets, ensuring that a shipment cannot simply vanish into the commercial stream without explaining the deforestation associated with its origin. The integration of these systems marks a critical development in global policy. The shift towards viewing agricultural illegality as a global security issue rather than solely an environmental concern. This perspective acknowledges a darker reality. Illegal land conversion for agriculture is often driven by organized crime and systemic corruption, factors that can actively destabilize entire regions. The profits from these illicit commodities often fund networks that operate far outside the law. Consequently, this approach necessitates deep cooperation between producer nations, consumer markets, and intelligence agencies to dismantle the illicit trade networks that fuel these activities. The ultimate goal of integrating technology like satellite surveillance with legal frameworks like FLEG is to create a closed loop where illegality becomes economically unviable. If a producer cannot prove the land was legally cleared, they cannot access the lucrative markets of the developed world. By making it difficult to launder illegally sourced commodities into legitimate markets, and by providing verifiable proof of legality using satellite forensics, these systems aim to disincentivize deforestation for commercial agriculture. The objective is to construct a global market where sustainable practices are not just an ethical choice, but the only operational model that survives. True resilience in the global food system necessitates strict adherence to the rule of law, enforced by rigorous technology. When the origin of a commodity is obscured within the supply chain, the entire agricultural network is compromised. Addressing the massive volume of carbon dioxide released annually by this illicit trade demands more than voluntary pledges. It requires mandatory legal verification to ensure the market stops funding its own destabilization. If you enjoyed this video, don't forget to like, share, and subscribe to the channel.